Alright, today we're starting with our video notes and for our chemistry unit. We've been talking about properties. I gave you all those notes. You didn't have to write anything. And then we talked on Friday about models of the atom and the history of discovering the atom, and you did that in timeline form. And today you're actually going to have to take notes the old-fashioned way. So everybody's in their notebook. They're going to label the top of this, what is matter, why does matter matter. And we are going to start with the definition of matter. And matter can be defined as anything that has a mass and a volume. So it takes up space. You can measure a mass. We've looked at, last week we looked at melting points and boiling points in the different states of matter. And we watched the brain pop video, and solid, liquid, and gas are the common states. The plasma state is also found in stars and in our fluorescent lights. And we also, they mentioned the colloid state, which is a special type of solution or liquid state. And atoms are the basic building blocks or units of matter. So everything is made of atoms. So if you will get this down, we'll pause for a second and let you get your notes finished and get this list done, and then we'll move forward. Now, when I started class today, I showed you some ice and you watched it melting. And last week when we were doing melting points and boiling points and states of matter and watching the video clips, we all said that when something changes from a solid liquid to a gas or a gas to a liquid to a solid, there is no chemical alteration of that matter. It's just changing states due to what temperature it's at. So that is what we call a physical change. You also watch me put some hot sauce, which has acetic acid in it, on some dirty pennies. And we started with dirty pennies, and now they are clean because that acetic acid reacted with the tarnish, the oxidation that had happened to the copper pennies, the copper oxide, and it removed it. A chemical reaction took place. So in a chemical reaction, there is a change in the matter. Now, the matter is not disappearing, but chemically, it is changing and forming something new. So that's what we're going to look at next in our notes, is the difference between a physical and chemical change in matter. So when matter keeps its same chemical or atomic makeup, then it is a physical change. So ice melts to liquid water. H2O is still H2O. It's just solid H2O. It's liquid H2O. Now you may see change in form, solid, liquid, gas, that type of thing. You may even see a color change. For example, I could paint these black desks red and they would still be made of the same polymer and metal that they are. They would just be a different color. That would be a physical change. A chemical change occurs when you get something brand new. So if you look at the chemical formula, when water and oxygen react, they produce hydrogen peroxide. And most of you have all had a cut and put peroxide on it and seen it bubbling and fizzing. That's another chemical reaction. When hydrogen peroxide reacts with oxygen in your oxygenated blood, it starts releasing some oxygen atoms into the atmosphere, and so you see a second chemical reaction taking place. So in a chemical change, you're forming new matter. So when the acetic acid dissolved the copper oxide off the pennies, we were left with the copper paint coating on the outside of the pennies. We cleaned them up by dissolving that tarnish. And that tarnish, that copper oxide, and that acetic acid have formed some new chemicals that are down in the liquid that we rinsed off the pennies. So we didn't get rid of anything. We just changed its chemical structure. And that is a chemical change. So if you haven't gotten the definitions and the examples down, please do that. And you can always ask yourself the question with a physical and a chemical change. Did I make something brand new, or did I just change the way what I had, how it physically looked? And those are the questions to ask yourself. So mixtures are considered physical changes because in a mixture, like salt water or sugar water or iced tea or coffee, all you're doing is dissolving a solid into a liquid. And if I let it sit there and evaporate for several days, the water will change into a gas and evaporate into the air, and I'll be left with the coffee crystals, I'll be left with the tea crystals, the sugar crystals, the salt crystals. So physical changes, you can get back your original chemicals. Chemical changes, I can't get it back without carrying out another chemical reaction. So it doesn't. So a chemical reaction, you're getting all new atomic structure. So notice again how the molecule changed to two molecules of H2O2. So we now have two oxygens here and one here. So they have changed structures. And that's going to be all of our notes today. And then later in the week, we'll start talking about how do we classify these changes. Today, you're going to play a game with trying to identify some chemical and physical changes. I'm going to give you some questions to do. And then tomorrow I will do a demo of about 6 or 8 different changes and let you decide if you think it is a chemical or physical change.